Hi, welcome to the second tutorial from week 2 of the course Cartographic Visualization in GIS. First of all, I would like to apologize for the quality of the videos we uploaded last week. We noticed that the screen recording was not best quality, so we have increased the quality. Hopefully it's better this time. Yeah, so today we are going to work with a couple of things. First thing we will start with is a global map. We are going to use a dataset, an open dataset of airports around the world and create a world map of the airports, visualize the traffic of each airport and the routes between the different airports around the world. So that's the first map we are going to make, a global map. The second map is a static local map that we will create from Helsinki area using a PPGIS data, and I will explain more about that later on. But let's go to our work folder inside tutorials. I'm going to pull the latest changes from the repository. We have uploaded the materials for the second week, so let's just pull the changes. Do not push your changes from last week. You don't have permission to do that anyway, but it's enough if you just pull the latest changes. Okay, so the file should be there. We have a new directory called week 2, and here we have everything that we should need for doing this tutorial. So let's start uh, with the global map. This is the Python version tutorial, of course, and we are going to do the Python version. Tato will do it separately in a different video using QGIS. Some of the tools that you might find useful here, the color palette, we talked about this during the class. Of course, you can use it here to find the suitable color for yourself, for your work, or you can, of course, use any online tool that is available to you. But I will leave this to you to explore. Let's just start with the first map. As I said, we are going to make a global map of world airports. A lot of the libraries that we are going to work with are familiar for you. Well, we are working with pandas, GeoPandas, Shapely, and Matplotlib. But one thing that is new and is interesting to learn is CartoPy library. It's a Python library designed for cartography and geographic data processing. So it makes map creation it makes it more interesting. So the output will be interesting, better looking compared to Matplotlib. So one of the key features of CartoPy is the way it handles projections. So you can it helps you visualize things more nicely, as you will see during this lesson, but also it saves you some time because it can handle projections on the go. So it's a bit more automatic compared to working with GeoPandas, where you have to explicitly be very careful with coordinate systems and convert to coordinate systems and then visualize with Matplotlib, which is not always, the looks will be different, especially when it comes to global maps. So CartoPy is a very interesting library to explore, especially if you're going to create global maps like the one that we are creating right now. So of course we will learn some of the features of this library now, but it's a big library, so there are many features. Check out the link here, which leads to the documentation, and learn more if you are interested. The data we are working with comes from openflights.org. It's an open data set of airports. It comes in two files. So one of them contains the information about the airports, and the other one has the information about the the routes between the airports. So how many travels, we can calculate how many trips are done on each airport, from each airport or to each airport, and from where to where. So these are the two files that we will be working with. So let's get it started. We start by, as usual, we start by defining our path, and then importing a number of libraries that we're going to use. So let's just do it right here. So I'm going to go and load the first data set, which is the airports data. It comes in DAT formats. We are going to read it with if you open it, you will see it's in CSV format. and the delimiter is comma. So I'm going to load these columns from the data and print the head to have an understanding of what we have in our data. So we see that we have, of course, the index and the ID number for each airport, the name, the city, the country, and then short names of the airport from IATA or ICAO, ICAO. So, and we also have the coordinates. So this is not a geospatial data. Like we have the latitudes and longitudes. Of course, we can make it a GeoPandas, geodata from a geodata frame, and that's what we're going to do next. But it didn't come as a geospatial data ready to use, so it's not in shapefile or geopackage, but that's easy. We are going to take care of that. There are other information, other columns that we do not really need in this tutorial, but let's continue and create our geodata frame. So as you can see, the latitude and longitude are separate columns, and you probably remember from the AutoGIS course, or if you have done Python for geospatial analysis before, you know that when we are creating a geodata frame, we need the coordinates as a tuple. Of course, there are different ways of doing that. You can do this more manually, writing a for loop, like handling the text. There are many ways how you can do that. But one easy way is to use the built-in function provided by Python, a zip function that combines multiple iterables like lists or columns into tuples, pairing elements by their position, which is perfect for us because we want to create tuples of the coordinates, which we can use to create the geometry column of our geodata frame. So once we do that, then we have the geometry column. We specify the coordinates, which I know about from the documentation coming from the data. And that's it. I should have my geodata frame ready. So before we continue, let's make a very quick map to see what we are dealing with. So there's nothing really new here. We are using matplotlib to create a plot. Well, we are already using here the CartoGIS. So as you can see before, when we were using matplotlib and GeoPandas for visualization, we always handled the coordinate systems, and then we came here and we just quickly plot. But when using CartoGIS, you can handle the coordinate system on the fly when doing the visualization. So what I'm doing here, I'm creating a map, and I'm specifying what projection I'm using for my map. So Robinson is a good choice here, but we can go with different projections, but Robinson in our case would look nice, and you will see. And then you should specify what is the coordinate system of the data you are visualizing. And this is the coordinate system that we are going to use. Well, the data comes in, and what CartoGIS does is that it takes care of the required projection. So things are a bit more automatic. So I'm also applying marker size, alpha, fully, no transparency at all, and applying some color. This is a preliminary map, and we are going to revisit this several times, improving our map. So this is what we have. And we have set a black background, which looks nice. And this is our map. So we are going to work further with this. So you can see we have a lot of airports from all around the world, and we will continue working with this. So there's a bit of explanation here comparing our old approach, working with GeoPandas and directly converting or transforming the coordinate systems and then plotting them, or using CartoGIS together with Matplotlib, similar to what we did up here, to do the plotting, projection, and everything on the go a bit more automatically. So there's a brief comparison. But GeoPandas works fine. Well, we can use them both for flat local maps, but where CartoGIS gets to shine more is with global maps where you have curved projection. With GeoPandas Matplotlib, you cannot show that curvature of Earth. With CartoGIS, it can handle a projection so that you will see the curves. So, and this is something we are going to do now. So CRC transformation is manual with GeoPandas. You have to write it, but here it's automatic. So you just specify the projection, the transformation, and things happen. Then it also handles the coastlines and base maps. With CartoGIS you can do it directly. So this is something we are not working with, but this is particularly important when you're working with large areas or global maps like we are doing. So why use projection and transform CartoGIS? So remember, the projection is setting the map projection. So in this case we use Robinson, and then transformation is telling you that your data is coming in a certain coordinate system, and the transformation is then done automatically. So let's load the other data file. So now we have the airports loaded. Now we want to work with the routes. So again, the data comes in a separate file called routes.dat. The limiter is a comma. We are going to read it and print the head to see what we have. So yeah, so this is data. We know the source airport and the destination, and we have the names as this short names, so we can use this for joining our data sets. So I'm going to clean up my data a bit, only keeping the airport data, only keeping the columns I need. You remember the airport's data had more columns, so I'm going to clean that. And yeah, so only keeping name, the IATA and ICAO name and latitude and longitudes. Then what I'm going to do is to create different geodata frames for my visualization, because now airports are all combined, but I want to separate it into source and destination. So what I'm going to do is to make a copy of my data and then making a selection based on whether it's a source or a destination airport, and saving them in separate geodata frames, source airports and destination airports. This makes our life a bit easier when making the visualization. So now that we have the two separate geodata frames of airports, so I'm going to filter the route data frame. So also a bit of cleaning on the route data, only keeping the source airport, destination airport names. The next thing we are going to do is to do a special join. Remember that a special join is the term we use when working in software like QGIS and ArcGIS, but in GeoPandas world, we use the term merge. So we use the function merge to do a join. Sorry, it's not a special join, but a regular join based on a common column. So we are going to do the join or merge between the two data sets, so the routes and source airports, based on the short name of the airports, which was named differently in the two data sets. And then once we do the first join, we are doing a second join with the destination. So we get all the information of the source and destination airports into one geodata frame. So this is done. Now if you look at the columns that we have in our data, we should have everything. We know the source, we know the destination, and other information about the route. So what we are going to do next, so we already visualized the airports as points on our data, and that was easy. We didn't even need CartoGIS, or we didn't do anything fancy yet. But now we are going to continue and add these lines to the map, and now we will see why CartoGIS is a nice addition to our work here. So what I'm going to do is to create lines. So we know the routes are only origin destination, so we don't really have a line. We have to create the line based on the origin and destination information to visualize the route. And that is easy to do because we know the source and destination airport, and we have the coordinates for them. So what we are going to do, we are using Shapley's line string geometry. So we have talked about Shapley a lot in the AutoGIS course. So if you haven't forgotten, or if you have forgotten, or if you haven't taken this course, check out this link to learn about Shapley and how it can be used to manage geometries in GIS. So I'm going to use Shapley to create a line, and then we visualize that line. So I'm importing the needed geometry. I'm going to create a line string because I want to visualize the routes as lines. And then I'm creating the geometry based on the origin and destination coordinates. and then I'm just converting it to a geodata frame. So let's just run this cell and create our geodata frame. Data is big, so it might take a few seconds to run. Yeah, so it's ready now that we have created the geodata frame. Let's quickly visualize it to see what we have. So this is what we have. These are all the lines between source and destination airports. It looks messy, and as cartographers, our job is now to create a better map. So the way I'm going to make this map better is that, of course, I will play with the colors. I will play with the widths of the lines to make it a bit less crowded. Another thing that we are going to do is that, well, this is on a flat, this projection is using a flat visualization. So this, like, we are using a flat visualization here because this is simply matplotlib. And we know that it's a global map, and for routes to look a little bit nicer, it would be good to take into account the curvature of the Earth. So instead of visualizing the lines on a 2D surface, we would have a more realistic visualization showing the line considering the curvature of the Earth. So we would have curved lines. And that is where we need CartoGIS, because Matplotlib cannot do that for us. So let's create let's recreate the map with these changes. So we are going to use CartoGIS. So same as what we did at the beginning. The Robinson is the coordinate system that we have for our map. One thing that we are doing differently here, in the transform, we are using geodetic instead of the name of the coordinate system that we used earlier. And this is essentially telling CartoGIS to use a geodetic surface for visualizing my lines. So for the points, I don't care because the curvature doesn't affect it so much. But for the lines, I'm going to use a geodetic surface. So we will show the, then I'm adjusting the line width, making it a bit smaller, applying color white, adding a bit of transparency, and that's pretty much what we're doing here. Let's run the cell. So takes a few seconds with all the calculations and projections happening on the background. Okay, so our map is now loaded. You can see that we have a map. The lines look much nicer because we adjusted the visuals, but also this curvature looks nice and more realistic when creating a global map as such, that in which we have lines crossing across continents. So this is what we did using geodetic as the coordinate system. So you can play with this. You can use the same as same projection that we had earlier, and you will see it will appear as flat lines on the map. But geodetic looks nicer in our case. So we have other variables we want to add to the map. Well, we don't have the airports. We will add the airports as points. But we want to also add another variable, and that is the number of flights from and or to the airport. So we want to kind of visualize how big the airport is based on the number of flights it has every day. So what we are going to do, we have to do a bit of calculation. The data wasn't ready in our, well, it didn't come with the data, but we can count. So from our data, we can count how many flights have happened from that airport, how many flights have happened to that airport, and then we can even calculate the sum. So we get the number of total flights that are happening in that airport. So this is what we are going to do, doing counting how many times the flight, the airport has appeared as a source or a destination. So once we do this calculation, now we are going to convert it to a data frame, a pandas data frame, doing the same thing for the destination count, and joining them together. So we bring them together And then another thing we are going to do is to count the sum. So we have the count separately for the source, where the flight has been where the airport has been a source or a destination. We are going to sum it up and save it as a column called count, which is the total count of flights for that airport, combining source and destination flights. So we are going to continue. So we are going to merge the counts, the data we just created, with the original airport data we had, and we are going to use the short name of the airport, which was called airport in one of them and IATA in the other one, and then converting these to a geodata frame that we can use for visualization. So now I want to, so how do we visualize how big the airport is? So for doing that, I'm going to create a proportional symbol map. So the size of the symbol for each airport will be proportional to the number of flights, the count that we just calculated. So I'm going to create a column called marker size, and I'm going to calculate the count divided by 10. So this is by experiment. So to get the right size, I'm dividing the counts of the flights by 10, and then I'm using this value to adjust the size of the symbol showing the airports. So I'm going to recreate the map. So we are repeating the same thing, but this time adding also the airports. So this is the same projection as Robinson. For lines, we are using a geodetic visualization, showing them as curved lines on the map. And now we are adding the airports, and specifying that the marker size is coming from this column that we already calculated, and adjusting a number of things and applying a color. One thing to note here is that here for transformation, we are just using the projection system that the data came in, and we are not adjusting that. Of course, you can use geodetic, but it wouldn't make a difference because we have points as our, it doesn't matter if it's on a curved surface or a flat surface, because we are visualizing points. So in terms of visualization, it doesn't make a difference. So I'm going to run this and see what we get as output. Of course, you can play with this, put geodetic here to see what the output would look like, or copy this and put it instead of geodetic here and see that the lines will start to look flat, not curved anymore. So you can experiment a bit and see why we have made these choices. But now this is taking a few seconds. We are creating our map. Okay, I guess we forgot to run one column, one cell. So let's run the cell. Yeah, I guess we missed a few steps. So I go back here, run the cells that I didn't run. So we have a bit of explanation, what I just basically said, why we have made such choices and used different terms for the transform. Okay, now we got the map and it looks quite nice. You can see the sizes of the symbols of the airports reflect how big the airport is or how many flights are happening per day in that airport. So the color we have applied here to the symbols, the airport symbols, is just the built-in color map from the library, from the Matplotlib library. So because we haven't specified what this color is based on, what is happening is basically it's just it's applying a color based on the longitude, so in some order. So it's ranging from blue to red. So this makes our map look nice, but it doesn't really give you much information. In a different case, you might have used this visual variable, this color, to portray another dimension, to visualize another column in your data. In this case, we don't have any other columns we want to visualize, so we are just going with longitude, just making our map look a bit nicer. But like I said, this can be set to show something else about the data. So the color can show some of the information from your data. Yeah, so this already looks good. I'm going to further adjust my map, add a few things, and then we are done with this. So what I'm going to do now is to still adjust the color map. The visual hierarchy here is too much. The colors are too bright. And since this is not really, so back to the topic of visual hierarchy, the colors are very loud here, but the colors don't really give much information because it's just based on the longitude in our case. So I would like to keep the color to make my map look nice, but I don't want to have it as a top visual hierarchy. So I'm going to change the color to something more neutral for that purpose, to reduce the visual hierarchy. So I go with the color range cool warm, which is not as loud as this one. And then I add a title to my map and a legend. So adding some elements to my map to make it more readable. So this is what I'm doing. We already learned how to make legend, and adding title is easy. And yeah, just let's quickly look at the map. We are going to, well, most of it is just repeating what we had done before. Adding the lines, adding the points, and readjusting the color map this time. Then we are adding the legend and visual, like adjusting how it looks like, adding the legend to the map, and then a title for the legend, and then setting a title here for the map. So this is the text. You can modify what font size you want to use, apply the color. So during the lecture this week, we talked about colors. So you can, of course, use some built-in colors. Here you can write orange or blue. Matplotlib knows the main colors, but you can also provide this hex code that we learned to work with during the course. So you can find this hex code. There are a million online tools where you can get this, or you can get from a software you have on your computer. I don't know, Paint, PowerPoint, or this color pickle tool that we have included here. You specify the location where you want the title to appear. I put it at the center. I'm going to make the font bold, and you can specify what family of fonts you want. I add a bit of padding, so there will be a bit of gap between the title and my map. And then if you want, you can save it as a figure. I'm going to save it as global flight routes.png right in the root folder. And that's it. So let's run this and see what our final map looks like. As you can see, compared to just making a quick visualization in Matplotlib, this takes a bit longer because we have all these projections happening on the fly when creating the visualization. So that's why it's a bit heavier, but it doesn't take too long. This is the visualization, so I'm happier now with the colors. It's not as dominant as it was before, and I have chosen a color for the title that is a bit harmonious with the colors we have on our map, and I've added the legend here in this empty area so it's not overlapping with my map or data. And in the legend we have the routes and the airports added. So this is our final map, and it's been saved as a figure PNG format, and that was the first part of our tutorial. Okay, let's now move on to the next part of our tutorial, where we are going to work with PPGIS data. So let's find the file, PPGIS Python. So many of you might be familiar with PPGIS, Public Participation Geographic Information System data. So it's a survey that has a mapping function. So individuals, the participants, can go to the map, mark something on the map. This is usually a point, but it can be any geographical feature, any kind of geometry, and they express their opinion. So in this case, this is an anonymized data coming from a research group I used to work in Aalto University, and there people were asked to express their feeling about the place very simply. Is it a positive place or negative? Do you perceive the place positively or negatively? So the data has been simplified, anonymized, and published on Zenodo repository, so you can browse what are their data sets are published there, and we are going to actually revisit this in our exercise. But the column that we are going to work with is quality, and it has two values, positive and negative, showing people's perception. So we are going to do a number of things, adding a base map. We are going to make a simple point map, a local map, and then we are customizing it by adding base map to our static map. We will work with classification a bit. We will see how a few tricks. How this is a very like crowded data, a lot of points with contradicting values in the same spot, in the same area. So visualizing it is a bit challenging. Like making a good map is challenging. So we are exploring a few tricks how we can deal with such kind of data when it comes to making maps. We continue adding legend to our map. We will have we will add a scale bar. One other thing we learned today is to add custom symbols as figures. This is something we talked about in the first week. Now we are going to do it, adding a symbol, a picture as a symbol. And then at the end, we will see also how we can create a kernel density map using Python, which might be useful for this kind of data. We are going to use a number of libraries in our work. So many of them are familiar. NumPy for doing some mathematical calculations, then the good old pandas, GeoPandas. We are going to clip our data using Helsinki boundary. So we just quickly get the boundary from OSM using this library we have seen before. Then Matplotlib contextually for adding a base map. TileMapBase is another library for adding a base map. Just they basically do the same thing. I'm just showcasing you, just showing you that there are other options other than contextually that we have learned about in the first course in AutoGIS course. And then we are going to use Seaborn, which is another high-level interface for attractive statistical graphics, and it will help us to create a kernel density map in this tutorial. So let's start with data exploration. We define our path as usual, and then we are loading our data. It's a shapefile saved in our data folder, and we are getting the number of rows in our data, see how big of the data we have, and quickly plotting it. This is quite, well, you see there are a lot of points. Well, we have the large data, so 6,600. A lot of them are overlapping, so let's just make the marker size a bit smaller, so maybe it looks a bit better. Well, it's still very crowded, so we are going to work with this and make it better. But first things first, as you can probably imagine, this is where the data should be from. This is the Helsinki area, and these are just blunders that I'm going to remove from my data. So data cleaning is of course part of map making. If you have blunders in your data, of course it can it will affect our map in a different way. In this case, it will affect the extent of my map because I want to just zoom on Helsinki area, and it's a much bigger area. So I'm going to remove these points. For doing that, I'm just going to get quickly the Helsinki boundary from OSM. This is something we have done in the first week, and we have done it a lot in AutoGIS course. So you can refer to those to remember what we are doing here. But I'm just getting the coordinate, getting the boundary of Helsinki, taking it to the right coordinate system. We are going to do a special join on this, so it's important to make sure that the coordinate systems are matching between our data and the boundary. And that's why I've added this assertion here to double check. Then I'm doing the special join here, getting all the points that are within this Helsinki boundary. So essentially I'm filtering my data, getting rid of those blunders which were outside Helsinki area. Then I'm going to create my point map, very simple map, turning off the ticks and the axis on the map. So to make it look better, just applying a brown color, marker size 3, nothing new here, except that I'm adding a base map, which is a familiar thing for those of you who have taken AutoGIS courses. With Contextly, there are a lot of built-in base maps that you can just use. Well, this is OSM, Mapnik. We are going to use that for our visualization. So a base map is good to give some context. Of course, it's not a must. Very often it's a lazy solution, but it can be also good. So it really depends on what kind of map you are making and what kind of data you have available to you. But sometimes it's good to have a base map to add a bit of context to the map, but it's not always the case. So I'm going to check the unique values we have in quality. I'm doing this because I know there's a mistake in the data. Well, negative is written in two different ways. So many cases it's N with a small letter and sometimes with capital. So I'm going to make it consistent, replacing replacing the having everything in capital, so it doesn't affect my visualization. So I'm going to run this and replace all the negative with n, small n with n capital. So it's important to check the data quality in case there are problems. In this case, I spotted the problem. Then I'm going to visualize this. Of course, the data has to go to a global coordinate system because I'm using a base map here. Then what am I going to do? I'm going to visualize the map, the features based on the positive negative value. So we will have a binary visualization. So of course there are a number of ways you can do this. Well, since we have two values, you can just use a built-in C map, a color map. So you can just put plasma here, for instance, or you can define your own colors. So I can decide what to assign as positive and negative. So you just provide the hex codes here and do the visualization. So here as CMap, you can use what you have defined using the listed color map, or just use some of the built-in ones. So I don't want to add an edge color. With this many points, the edge would just make the map look crowded and unreadable. And then adding some keywords to the legend. So the title and the location where I want the map, the legend to appear, which is the lower right corner of my map. Then I'm adding a base map, adding a bit of transparency to my base map, turning off the axis and the ticks on the map to make it look neater. So let's look at the map. So we have the visualization. I have used my own custom colors. Positive is visualized with a shade of green, and the negative a bit more reddish pinkish color. And yeah, and I've chosen a less loud base map here because in the first example the base map was just too colorful, too much for our purpose. We just want to add a bit of context here to know where we are, but we don't need all the details on the base map. So again, depending on what you're doing, you choose a proper visualization approach, in this case a base map. So this is good. This gives you already a sense of distribution of positive and negative points. It might be enough depending on what you want from the map, but I'm going to explore this a bit further. So I want to do visual analysis. I want to identify the clusters of positive and negative markings. So here, as you can see, they're very mixed. So it's a bit hard to say which area is more positive or more negative. You might be a bit biased because you don't know how these are, because of the order on which the map is created. The layers are added, so it might look more like pink in some place or more green just simply because this layer is drawn on top of the other one. So this can be a bit misleading. That's why I'm going to use a trick. I'm going to do a grid-based representation, which is a useful trick for this kind of visualization. So I'm going to create a grid covering my whole study area, and within each grid cell I'm going to calculate how many positive and negative points I have. Then within each grid I know what is the dominant sentiment. So what is the dominant perception? Is it more positive points or negative points? So this is a useful way of visually analyzing my data, getting a sense of what areas are dominantly perceived as positive or negative. So I'm going to, well, you can get the grid from wherever. In Helsinki, for instance, in Finland, we have this Statistics Finland grid network that you can just download from Python or fetch it from WFS and then just use it. In my case, I'm going to create my my grid. So I learned how to create the grid, and then I can just apply it wherever, because the point of using Python for cartography, a big point is to automate things. So with this, I can just apply the same approach to a data set coming from anywhere in the world, just creating my own grids without depending on availability of grid data. So I'm going to create a grid of 250 by 250, and I'm going to create this based on the extents of my data. So I read the minimum and maximum x and y from my data. Then I create the coordinates just based on the distances and of course where the minimum and maximum coordinates based on this range. So I'm just going to create the coordinates for my grid, and then I'm going to create a geodata frame based on that. So I just put them in a list, I append it to the list, and then I just use the coordinates, and I apply the CRS to create my geodata frame. So let's just run this. So we have already done one special join here on our data when we were doing the clipping, when we were doing the data cleaning. So one thing that happens sometimes when you do a special join, it might leave behind some columns, index right and index left. So it could happen that you redo a special join and these columns already exist and you get an error. That's why I've put it in a try except. I've put it as try and accept. So if the fields exist, just drop those fields. Of course, this is one way of doing that because we don't need these columns, we just remove them. But if you want to keep them, of course, you can explicitly specify what names you want to use instead of these when you're doing the special join. But I don't need those, so I would just drop them if they already exist. They didn't exist, so that wouldn't have been a problem. Just being cautious because this sometimes happens. Now we do our special join to get the counts. We want to get our goal is to get the counts of points for positive and negative to each grid cell. So for that, we are joining our grid with the points in Helsinki. And then, yeah, so one condition is that we want to only keep points that are the only grids that have points. So if you have a grid, the grid is covering the whole area. If you don't believe me, you can just visualize this grid with dot plot. But yeah, I want to just keep things that have a point, at least one point. So I'm putting this condition here that there has to be at least one negative or positive point in that grid cell. So not visualizing every cell that doesn't contain the data. So now you see that the grid is not covering the whole box, which it's because of our filter. So these are grids that actually have a point inside them. So yeah, so this is our grid cell. Of course, you can just visualize however you want. So this is not necessarily a visualization trick, but very often when creating visualization, it might be useful to do a bit of math. So this math can be just some classification, or in our case, I'm going to create a positivity score using a very simple formula. So positive minus negative divided by the sum of the two. So this gives me a positivity score that I can use to visualize. So I will have one number. So this is a trick. So if you can come up with a formula with some kind of calculation that can facilitate your visualization, and of course, as long as it makes sense, depending on what you're visualizing, this is one way to go. So here I'm doing the calculations, creating the positivity score as a column in my data. And then I'm going to visualize this. So this is the positivity score. So we have a value ranging from -1 to +1. So we can see in which cell we dominantly have a positive value. So these red ones are clearly negative areas. Then we have areas which are a bit mixed, a bit yellowish, and then we have areas that are clearly positive. So this is what we have. Of course, this is not a good visualization yet. We are going to improve that because we have too much granularity in our data, like too many things, so it might a bit overwhelm the reader. So I'm going to also apply a classification. And we remember from AutoGIS course that this is easy. In Matplotlib, we can just provide a scheme which defines, there are a lot of built-in classifications. I'm going to use natural breaks and classify my reclassify my values. So now it's a bit simpler. So instead of all these little details, I have bigger classes of values. So yellowish is like neutral kind of, then green is positive, and red is negative. So this is now what I have. It looks a little bit better. I'm going to work further with my map, add some elements. One thing I'm going to add is a scale bar. And for a scale bar, we have different ways of doing that. One way is to install a submodule of Matplotlib called Matplotlib scale bar. It's not installed in our environment, but if you want to try this out, just use pip install. You have to put an exclamation mark at the beginning, so remove this sharp sign and put exclamation mark, pip install Matplotlib scale bar, then try this. This is good for many purposes and it's easier, but there is a more advanced way of doing this. It takes a bit of manual work and some calculations, but it's more accurate. So I'm going to do the manual way, but remember that there is a more like automatic way of doing this. So I'm going to do this manually. So I'm creating the visualization again. That's not new. What the part that is new is where I'm adding the scale bar, and for that I'm using anchored size bar. So I'm just manually adding a line and calculating what should the size of the line be. So you can specify, you should specify a length for the bar. So if I want a line of 1000 meters, I can just provide 1000 as the length of the bar. So I'm manually creating a bar. So the problem here is that if you see, well, the scale bar is added, I've added a bit of text to it and everything, so it's appearing as it should in the place upper right. But the problem is that the size is off. So this is 1 kilometer, and these are supposed to be 250. So you can see that this is not 4 times bigger than the edge of this grid cells. So there is something off with the sizes. So as you might have guessed, the problem is coming from projection system, because in our work we are using Mercator. We are using Mercator because we are using base map, so we are using Web Mercator. And as you know, Web Mercator does not respect areas and distances. So what is happening, and we are now in Finland, so we have a lot of distortion in this area. So that's why, because of this distortion, the values are not matching. So in order to fix this, we can adjust the length. So this I've gotten from somewhere. So this is some calculation you can do for the Mercator to adjust the distortion. So if we do this calculation, then we can use the adjusted length. We can calculate an adjusted length that we can provide instead of length here. So I can just put it here. So this is adjusted. So this looks more correct, like almost, well, it should be 4 times bigger than the edge of this 1 kilometer. So remember, depending on your projection system, especially if you're working with Mercator, Web Mercator, you will have distortion. So if you're adding the scale bar manually, you should be careful to fix that before that. So now our scale bar is added. We have our legend added. What else should we add? Okay, landmarks. So again, I'm showcasing a few things you can do with your map. So we don't know the purpose of this map here, just teaching you tricks how to make to add different features to your map using Python. So very often, if you're making this map for people are not, for example, for tourists or people who may not be super familiar with the Helsinki area, but they might know some landmarks. So for example, they might know where is the railway station or where is the White Church. So you can add those as like adding those landmarks can make your map readable. Again, this depends on type of map, who is the audience, what is the purpose of the map. But I'm going to manually just, I've gotten these coordinates from some from OSM or Google Maps. So I'm going to manually add Helsinki White Church, Pasila railway station, and the Itäkeskus shopping center to my map to just give some orientation to my readers, to the users of my map. So I'm going to just create a geodata frame of these 3 points and specify the coordinate system. So this is my geodata frame. So now I can just add this to my visualization as a star. So I'm just using a star sign. Yeah, so I'm using a star sign to show, okay, this is Pasila railway station, this is it is shopping center, this is Helsinki White Church. I can further customize this by using figures. So if you have a picture of, if it is a touristy area and you have a picture of White Church, for instance, then you can use it as a symbol there. So I have already downloaded some pictures that I thought would look good, like a church or a train sign or a shopping center sign as PNG files, and they're saved under assets in here. So I'm just going to use this instead of symbols. So this may not be the best examples, but the idea here is that you can customize the symbols and put whatever image, whatever icon you have access to. So instead of the star, I'm going to use these pictures. Yeah. So here is this is where I'm adding it. So I'm adding these points using the PNG files, and in case there's a PNG file missing, it will just use the star instead. So if you have a bigger data to handle the error, that's why we have the else here. And the rest is just the same. So I'm going to run this and get my map. So you can see the symbols are added, the images are loaded from this asset folder. We have the icons, these 3 files. They're added to our map to give a bit of sense of orientation to our map users. And I'm also adding the labels here and specifying the font size and where it would appear on my map, as you can see. So this takes a bit of adjustment compared to the software where you would more automatically apply things. Here you need to adjust the location of text and the symbol and everything to make sure it looks nice. So this was one more thing we learned that might be useful for some maps. Another thing we are going to do, the last thing we are going to do with this data, is to apply a kernel density map. A kernel density map is useful if you are if you have a there are many cases where you might want to use that. In our case, it might be useful because we have 6,000 plus points with contradicting values like positive and negative. Many of them are coinciding in the same location, same area. So it might be useful for me to see to look at the distribution of them using kernel density function and just compare and see whether I can find clear clusters of hotspots for positive and negative points. So I'm going to use Seaborn for doing this, and also a different library, this time tile-based map for adding base maps. So this is just to showcase that this library exists and you can use it. But of course, you could have just used Contextly. Both of them are good. I'm personally more used to using Contextly, but many people use tile map base, and it is supposed to offer more flexibility and it's more scalable, but you can check the documentation and see which one works best for you. So I'm going to use tile map base and Seaborn, which I import as SNS, and then this is how you start your tile map base. You have to initialize the map, and then I'm creating the plot. So one thing we are doing a bit differently here, and this is a can be a useful trick if you are automating your map process. So instead of like what we have done so far in these two tutorials is that we have written the code, we have created the map. We haven't written a modular code necessarily. Here I'm creating a function called plot map that does everything. So everything we have previously done to create our visualization is happening inside this function. So this is a useful approach because if you want to automate things, so if you want to just call a function and provide input data and some parameters and recreate a map for different areas, for different places, with different styles, then this is a good way to go. So you define a function, you make your code more modular, and this way you can just call the function and recreate your map. So the function creates a visualization and also saves the output at the end. So I'm just going to run this. So the function is now defined. So now I'm going to continue working with my visualization. At the end, I'm calling this function to create the map. So I'm going to use, this time I'm going to use Seaborn kernel to create my kernel density map. So I'm defining the extents, I'm creating the density plot using SNS, the Seaborn, reading the X coordinates, Y coordinates, and whether you want to fill the area under the kernel density curve, you can set it true or false. Then adding a bit of transparency, what color do you want to add? So these are the same colors, we have color palettes. It uses the same color palette as Matplotlib. So if you want to just go with the built-in color, you can use it as the value in CMap or just define your own. And then drawing order. So you can specify a drawing order to adjust how things appear and then which axis you want this to be added to. And then I'm just sending this to my function, which I defined earlier, to create a map with the certain style that I want. So I'm going to run this now and wait for the output. So this is a kernel density map. Now this is based on points mix. As you can see, I didn't divide my points based on positive or negative. So I have just hotspots of points. So there are more markings in these three areas in my map. So next thing I'm going to do is to divide my data based on positive and negative values, and then create a kernel density map, a heat map separately for positive and negative points. For the negative points, I apply a shade of orange, and then for positive ones, I use blue, different shades of blue, and then I add the base map, and then this time it's just contextually, and I'm adding a legend, and that's it. So let's just run this. Yeah, so here we did not use the function because we are going a different way, but you could have just made the function in a way that you could have reused it here. But yeah, so what I'm doing here, I created two separate maps. And I'm overlaying the two layers. That's why I didn't use that function, because it was meant for just creating one map. But here I'm overlaying two layers on top of each other. So of course you can adjust the colors and the transparency to see how you can make this better, but I can see that there are clusters of positive and negative which are overlapping quite a lot. But if you look a bit more closely, you can see the direction is a bit different, orientated in different ways. So this allows you to explore the map visually a bit further. So this was how you can create kernel density using Python, using a Seaborn library. Okay, so that was our tutorial. Let's quickly look at our exercise for the week. Exercise 2, we are going to create two maps this week. One a static map based on PPGIS data. So in the same repository we used today for our data, for our second part of tutorial, there are other PPGIS data sets available. Just go to the repository, find the data set that you like, and just create a static map. So we have free hands what kind of map you want to create, what you want to visualize. Just explain what you're doing and why you make the cartographic choices you make, and explore the data visually in your own way. So do not duplicate exactly the same thing as we did in our tutorial, but just use what you have learned this week and create a good map that tells a story about the data that you have used. The second thing is a global map. We are suggesting a power plant, a global data of power plants around the world. There's a link to the data, so you can get the data, explore it, and visualize it. If you don't want to use this one, it's okay. You can use the same data set, airport data from our tutorial, but do not recreate the exact same map. So if you end up using the airport data, just create a different map, explore something else. Just explore another dimension of the data or visualize it very differently. So do not repeat what we have done in the tutorial. Or you can use, if you have another global data available to you from other sources. Well, if you Google, you can just find a lot of those. Feel free to use those. Just remember to mention what data you're using. So remember, this week we have talked about choice of colors, color theory, visual hierarchy. We have continued talking about projection, and this is very relevant, especially with the global map and the layout and many things that we have talked. So think about those when you're making cartographic decisions in your map making. So what to return? You will have two maps. One a static map from based on one of the PPGIS datasets that you have downloaded, a global map of the data you selected, and a short half of a page of reflection. So you will have reflection on what you have learned from the week, discussion, lecture, everything, and also a cartographic reflection saying that, okay, what do you like about your map? Why have you made certain decisions? And what would you make differently if you had, I don't know, different skills, or if you had more time, how would you improve your map? So this could a bit reflect on your weekly learning and the map you have made. So the grades come from the map, so 3 points for each of your maps, and we assess the quality based on what we have learned, based on these criteria and things we have learned this week and last week. And then you get 2 points from the map weekly learnings and the cartographic reflection. As usual, submit your exercise as a single PDF file to the Moodle. If you're using Python, no need to provide the code. And the deadline is next Thursday on end of day, 22nd of May.